Hey, Sam here and welcome to my channel. I post videos regularly of me attempting to solve LeetCode questions at random in the style of a mock interview. You may notice that I've actually already done this question before. I have the link above, and I'm actually doing something different this time. In this video, I'm going to talk about three specific choices I made. The first one was the visited data structure, choosing a set versus an array. The second one was modifying the grid in place versus using a separate visited data structure. And the third was my choice of using breadth-first search instead of depth-first search. I want to kind of go over the alternative options we had here and whether they were better or worse, in what cases, and just kind of discuss how one should be thinking about these sort of choices as you go between the two options. I think in the case of this question, I would have actually benefited from making some different decisions. Just as a quick recap, what this question is about is given a 2D binary grid, m by n size, with ones and zeros as characters, we're trying to find the count of all the islands inside of a grid. And an island is all connected cells, vertically and horizontally. So in this case, there's only one island because all the ones are connected. Here, there's an island 4 size, 1 size, and 2 size here, so we get an output of 3. And we're just returning the count of the islands. Looking at the code, I iterated through all the cells until we find a grid. So let's have a look at the step here. So for I and j through the ranges of m and n, we're checking every single cell. If it's water, we continue. We don't care about it. Otherwise, we start with that cell, check if it's been visited before inside of a visited set that we're going to build up. And if it's been visited before, we skip that cell. Otherwise, increment our island count because we found a new island cell. Flood fill that cell from all the cells that are connected to it, check visiting all those cells as well. That way, we only ever visit an island cell, either if it's been connected previously or if it's a new one. And at the very end, we return the island counts. That's the general logic for the question, and let's think about how we actually approach this. So a set and an array are technically both O of 1 lookup time, assuming that the set's amortization is pretty good, which in this case it will be, and that just has to do with whether there'll be a lot of collisions with the hash function. A set will only grow to the size of the island cells rather than the size of the whole grid, whereas an array would be the whole grid in this case. If a grid was very sparse, which means it was mostly water, the set would use less memory overall. Depending on the types of inputs we're getting, if we have really large empty grids with only a couple islands, I think a set would be a better option in this case. If islands were definitely a big part of the grid and or kind of varies all over the place, a grid is a very valid option, especially if dynamic memory allocation isn't as fast or so good. Kind of a pro and con you can bring up if the interviewer asks about it. The second discussion point is modifying the grid in place versus using visited. Let's have a look at that one too and create this pros and cons for it. The advantages of in place is no extra data structures, space efficient. The con is modifying original inputs might not be allowed. Fraught with peril is the way I'd put it. You might cause issues or changes to the original inputs without even realizing what mistakes are happening because it might pass a lot of test cases, and this especially tends to come up in coding in real life systems where you tend to want to avoid modifying things passed in unless you know exactly what you're doing with a lot of tests. In this case, I think it actually makes a lot of sense to be able to modify in place. And you might be able to do something like a grid.copy sort of thing where you can just create a copy of the passed in grid and modify that one instead, and we'll keep that in mind. The advantages of visited is more modular, easier to extend is the way I might put it. The con, of course, is new data structure, more memory access. It definitely can be slower in some cases. I think in this case it is slower. So this is not a ideal way to do comparisons, but I'll just submit here so we can see the timelines. And generally I've run this a few times and you'll see a variation that goes in the plus or minus 40 milliseconds just based on how the thing ran in the back end. Right there, you can see that it's in the middle and it tends to be right around this area. I think the key thing here is it might be a lot easier to code. That's the one that I think is relevant, especially to an interview. Let's go ahead and change up the code to show this. So we've modified this to no longer use a visited array. Instead, it's just modifying the grid and checking if it's an island and replacing it with an X if it's visited. So let's submit and see how it does now. You can see it's a little bit faster now. So the third thing I'd like to talk about is depth first search versus breadth first search. And we chose breadth first search here, as you can see, where we use the queue and we push and pop from it as we go through. We push in all the neighbors and we pop out cells as we go. The question is, was that a good choice? Technically, both have similar big O. However, depth first search tends to be a little bit more memory efficient, much easier to code than breadth first search. Good for optimal paths, etc. Not relevant here. Less memory efficient, I think. However, by default, we are using allocated memory instead of stack. So that is kind of nice. Here, one of the cons is DFS implementations tend to be recursive, though you can do it iteratively. In this situation, I actually think we would have done better with a depth first search because we are storing a lot of extra neighbor cells as we grow out for no real value, whereas I think a depth first search would have been totally fine, and it could have simplified the code quite a bit. So let's go ahead and see the code as it is right now and convert this over to depth first search. One of the first things I'm going to do is actually get rid of the collections dequeue and think about how we'd want to approach this problem. Let's get over to Go. I want to do this flood fill algorithm recursively. Instead of a while loop, check if the current cell is a island cell or not, else return. We'll do the check out of bounds right here. And actually one of the things I'd like to do is get rid of this tuple, which we don't really need anymore. We'll just use ints for the indexes. That'll just make this a little bit easier to read, I think. And these are no longer continues, we just return if any of these are true. We could combine these all into one if statement, which is totally valid actually, so why not? Let's just keep those two. Here we don't need to pop or pull. Instead, we know that this is a valid island cell. We'll turn it into a visited cell, and then we do every single neighbor and just call DFS, or in this case flood fill, on itself. So here we'll just do it for each neighbor of get neighbors. And let's actually see, I think this should work just as is. Let's think about what neighbor is. A neighbor is get neighbors of I and j. Do this neighbor cells. We don't need to do a check for if it's an island anymore because we'll do that within the flood fill. In fact, what I'd like to do is instead of having a whole separate function, we can even reduce this further because now we'll have this function handle the logic for that because it's already doing it up here inside of it. We'll now do flood fill on I plus IOI and j plus OJ. And if you want it to be even shorter, let's keep it as is like this. So first of all, let's run it. We have to do it here as well. We don't need the cell. Cool. Passes those. I think this will already make things a little bit faster because we're no longer having to create a DQ and build it out. However, we are using stack memory now when we do this recursive call to flood fill, and we could do this iteratively. This should be fine for the size of arrays we get here. Another little thing you can do is called unrolling of a for loop. In this case, we have a fixed size of just 4. So let's unroll that straight away. I minus 1, j, I plus 1, j minus 1, and j plus 1. And let's try that. And you can see how much faster it was here. Generally, I would see speeds faster or slower plus or minus 30 to 40 milliseconds. I'd say doing this flood fill recursively and unrolling this loop really speeds things up. And if one wanted to, at the end of this, you could actually modify the original grid to go back. So that is one way you could go about this if it was important to have the original grid returned back to its original style. You could also create a copy of the grid up here. We're not going to do that, however. The nice thing about using depth first search modifying in place here is we're technically now using O of 1 space, more or less, because we are just modifying the grid that exists. Still O of nm time, quite a bit faster and more memory efficient now that we're using depth first search. Good to see, very happy about that. So the things I wanted to talk about in this video were visited data structure, whether it should be a set or some fixed size structure. There's some pros and cons to that, as well as whether we should modify the grid in place versus visited. I think that was an interesting one too. Finally, I think the key one here was depth first search versus breadth first search. It's much easier to code. It's also quite a bit more memory efficient. We don't care about optimal paths, finding the shortest way from A to B or anything like that. If we were doing some sort of watershed algorithm where we're trying to find from multiple points on an island where the closest peak is or something along those lines, breadth first search would be the appropriate answer. That was not the case here. It had the advantage of not using stack memory by default just because of the way we implemented it. So there's no wrong answers per se here. It's all about being able to communicate the pros and cons. Like you want to weigh which one is better or worse, being able to kind of go over these with your interviewer when they ask. It's not about saying like, oh, you made the wrong choice. Sometimes it is, but in this case, I think any of these options are totally fine. It's not about when we talk about algorithmic efficiency, I think you can make any combination of these work and they would be appropriate for a specific use case. So no wrong answers here, but always fun to kind of go over this and just look at how much easier it was to code depth first search. You don't have an extra function for finding neighbors. You can do it recursively. Everything just kind of comes together. So you can imagine if you're in the middle of an interview, being able to get to some code like this with the interviewer is definitely a huge boon. Too bad I wasn't able to get to it straight away during the question, but I will be able to carry this forward for future questions. I think it's good to practice doing LeetCode questions. I hope this was interesting to everyone watching. This does take a little bit more time to edit and put together, but I think it is worth it. Let me know if you like this content, and if there's any other videos you'd like me to go over, let me know in the comments and I'll definitely check it out. Thanks for watching and see you all next time.